Hello, I'm Mr. T, and this is my Angular adventure. Hopefully you've already looked at my iPhone app, but this is a little bit of review related to that. So this is a definition of angle from wolfram.com, a great website. And the basic idea here is you have two intersecting lines or line segments, or often rays, and the angle is actually the amount of rotation that is in between those two, and the definition they give is the amount of rotation to bring them back together essentially. But the important thing to remember here, it's the space in between. That's what, when you're talking about the measure of the angle, it's the space in between. The angle itself is the two segments or two rays and the vertex, that point, but the measure of the angle is that space in between. So the next thing is we need a measure. How do we tell if an angle's a big angle, or how do we tell it's a little angle? And what do we call a big or little angle? And one of the issues here has to do with, how big is this thing? The way we've got it in this first picture is we've got it measuring 2 inches. But then in the next slide, we've got it measuring 1 inch because it's closer in, we're measuring 1 inch. So measuring it using a linear device is not really practical. So we need a different way to figure out how big these things are, how can we measure them, and then there's some also common names for them depending on whether or not we kind of consider them big or small. So here we have some different angles that you might kind of recognize and some names which are not matched up. They're in an incorrect order. So take a quick look at those and see if you recognize any, and then you're supposed to organize them from smallest to largest, as well as rearrange their names from smallest to largest, so you've got kind of a matching list there. So take a look. You may need to pause this for a second, think about what you want to do, and then come back and look at the next slide. So what we have now in our reordered list, this is all correct now. We have an acute angle, a right angle, an obtuse angle, and a straight angle. And most people are familiar with the right angle, or what many people will call a 90-degree angle. We'll talk about degrees in a moment. But the less than a right angle, a smaller angle, is known as an acute angle. Notice the space in between the two rays is smaller than it is for a right angle. And then more than a right angle, the third one down, obtuse angle, that's one that's more than a right angle, and yet less than what we call straight angle. Straight angle being really a straight line, but we can consider that a straight angle. And one of the things I like to tell people to kind of remember these, right angle and straight angle are fairly easy, but acute angle, it's a small angle. It's a cute little angle, so that's helpful for remembering that one. And obtuse is a big angle, it's a fat angle. And obtuse kind of looks like the word obese, so that's an easy way to remember that one. Obtuse angle is a big angle. So we start with a right angle and a straight angle because those are the most kind of obvious ones to most people, and talk about, well, how big are those? Can we put some kind of relative measure on those so we can measure other angles? And we can. So a right angle, we've already talked about, it's 90 degrees, and that's somewhat arbitrary, and I'll give a little history on it near the end of the lecture. But 90 degrees is what we say this size angle is. So something more than this size is less than 90 degrees. Something more than it is bigger than 90 degrees. We could also say it's half a straight line. We could measure everything in terms of straight lines, and this is half a straight line. We can say it's 1/4 of a full turn. If you're going to turn all the way around, spin around, what most people call a 360, you could do 1/4 of that. You can also talk about marching turns, like right face, left face. It'd be one marching turn. And finally, there's what's called radians, and radians is very much like degrees. It's another way to measure it. And 2 pi radians is 1 turn all the way around the circle. So 1/4 of that would be pi over 2 radians, and we'll talk a little bit more about that. Now for a straight line, that's 180 degrees, or you can think of it as 2 right turns. We could measure everything in terms of right angles or right turns. It's 1/2 of a 360, or a full spin around. It's 2 what you would call marching turns, so it's right face, left face, or about face. And finally, if we measure it in terms of radians, once again, 2 pi or 6.28 radians make up a full circle. So halfway around the circle, or a straight line, is just pi radians, or 3.14 approximately. So once again, right angle's 90 degrees, straight angle's 180 degrees. Notice the degree sign I've got on the 180, just like temperature. That's another way to write degrees. And then for below, you just want to approximate these measures, which is really, you just want to guess how big they are. So you may want to pause it for a second, come up with a guess for each one of them relative to 90 and 180. We're just looking for something that's close. And then we'll talk about how do you actually measure it if you want to know exactly how big it is. But a guess is often a good place to start. So hopefully you had a second to think about it and see how big these were. The one on the left is, I'm guessing, about 40 degrees. I haven't measured these. The second one, I think it's about 20, maybe about half of that. Once again, I'm kind of guessing. And the last one, it's obviously bigger than 90 degrees. It's an obtuse angle. So I'm going to guess 130. And this could be kind of off, but I'm probably pretty close. Now for this next section, I'm switching gears a little bit. I'm actually doing some live recording so you can see the motion on the screen here. So I want you to see how we're using this protractor here that's on the screen. A protractor is a device used to measure angles. And the way you typically do it is you put the vertex, that's the corner of the angle, right on the center. And then you turn the protractor such that one of the lines kind of parallel to the base lines up with it. And that line right there typically has a 0 and a 180 on it. 0 on one part and a 180, kind of one's on the inside, one's on the outside, depending on which side you're using. And ignore that, that's a mistake. So right here at the edge here, it says 0 on the inside and 180 on the outside. It's probably hard for you to see. And then at the other end here, it's got between a 40 and a 50 on the inside and a 130 and a 150 on the outside. So you're going to measure from that 0 on the inside up to what's about 45 degrees here. So this is really about 45 degrees, so I was a little bit off there. But that's about 45 degrees. Now if I wanted to, I could flip it around, which is what I'm doing right now. And so I line it up again, once again, it's still in the center. That one line has 0 or 180 on it. And the other one, once again, has between 40 and 50, and then 130 and 150, 140 on the other one. And so it's still 45. I'm just measuring, in this case, the numbers on the outside that I'm measuring. So whether you read the inside numbers or outside numbers, it depends on where did you start. Okay. So in this case, I believe I've got the 0 on the inside. So I'm going to read the inside numbers and I get 20 degrees. And here I've got 0 on the outside, and my outside numbers read 20 degrees. And then finally this one right here, when I line it up, it measures almost exactly. I gotta wait because I forgot. It's right at about 150 degrees. So that was a really quick explanation of how to use a protractor, and you can go out elsewhere on the web if you want more practice.